Chapter 8, Theory, Lesson 1. So, Chapter 8, if you have a look in the textbook, mainly deals with Excel and spreadsheets. So the theory that we're going to discuss in the videos, or this video, and hopefully the ones that follow, are going to be things like modeling, simulations, the difference between functions and formula. So these are the topics that we're going to be discussing in the slides that are going to come up in this video and the next one. But just let me know if these topics don't make any sense. So let's go through these. So what is the difference between a formula and a function? So remember, in Excel, we are dealing with formula and function. So what is the difference between these two? So a function is a built-in operation, such as sum, average, etc. So the functions that we would type in, so usually we'd say equals sum, equals average, equals SUMIF, equals if. These functions are built into Excel that we can use. So that is a function. A formula, also known as an equation, is something that the user defines and can use refer to various functions in it. So if we make up our own formula, we could say equals a1 plus a3. That is a formula. It's something that we have defined. Okay, we're not using something that was built in, like sum or average. A formula starts with an equal sign, such as equals d1 plus d2 divided by, and this is an absolute style reference to a3. They are similar in that both return a result based on the calculation that each performs. The difference is that a function is a built-in calculation, while a formula is a user-defined calculation. A formula could just use a single function. So as for example, equals sum, and then the range of cells that you want to add up. So it could be a single function, or it can have multiple functions involved, but it would be user-defined. So equals d1 plus d2 is an example of a formula. Okay, the function version of this could be equals sum d1 d2. That is an example of a function, a built-in calculation. We could also have something like equals average d1 d2 plus sum d1 d2. This is an example of a formula which uses the functions average and sum. So this is a formula that has functions involved in it, but this formula is user-defined. So the main difference between a formula and a function, as described here, a formula is user-defined, whereas a function is built in to the spreadsheet software. What is a model? So a model is a program which has been developed to copy the way a system works in real life. It uses mathematical formulas and calculations to predict what is likely to happen based on data recorded about what actually did happen in the past. The reason people use modeling and financial modeling in particular is that they want to predict the future. This is done by carefully setting up a model that they think will do this. Okay, so this is just a brief description of a model. You might have to know the definition. So if you compare this definition into your textbook, just make sure that it does make sense. So let's keep going. Give an example of modeling software. So spreadsheet software is an example of modeling software. So spreadsheet software like Excel, that is an example of modeling software. So that is probably going to be the most common example of modeling software that they're going to refer to in your textbook. Maybe. Any model needs a set of input values, a way to work on those input values, and then provide one or more output values. So especially in Excel, if you've set up a spreadsheet that has functions or formula in the spreadsheet, and you would put input values, so for example financial modeling, okay, so if you're having a business, you might put in values that you want to test in your model, and then your functions and formula are going to output values based on those input values. So hopefully we'll get to some examples at some point. A spreadsheet can deal with a lot of numbers, do some work on them, and produce some answers. So spreadsheets are ideal tools to use for straightforward financial modeling. Discuss the need of models. So why do we want to use models? So computer models are cheaper to set up than alternate methods that could be used to predict what will happen in a system. So for example, building a prototype, you won't need to do that if you want to use models. Models can be used for the purpose of training people to use equipment. So for example, learning to drive a forklift or fly a plane, we can use models to do that. Costs are saved because real equipment is not affected. Also, for example, if you're flying planes or driving cars, fuel does not need to be purchased, and the structures do not need to be present at all times if you're using models, and can be used for forecasting, so prediction of weather, what your profits will be like in a business, or predicting what the economy will look like, etc. And helps in the process of constructing buildings. Any adjustments in the real life world can be costly, so you can test out or try and design your buildings as ideal as possible in your model first, and then from your model you can construct the real life building. Benefits or tools that can be used to help with modeling. So it models instant automatic recalculation of formula, functions, and graph charts to answer what-if questions immediately. So just think of Excel. You can recalculate functions. Your formula will change if you change the inputs, etc. Your output will change immediately. If you have graphs, they can also change immediately depending on the values that are outputted. And if you have what-if questions, these can be answered from the data that you will see that is being outputted. So we'll talk about what-if questions in the next few slides as well. So if you tweak an input value, okay, so if you change a value that's been inputted into your Excel spreadsheet that your functions and formula are using to output information, you'll then immediately see the effect it has on the output values. It produces charts and graphs which show a graphical representation of the forecast. Conditional formatting to highlight the effects. So remember, conditional formatting, depending on the values in your cell, the background of those cells, the color of the background of the cells can change. So that will make information that you want to stand out. You can use goal seek to find out what variables need to be changed to achieve a given outcome. So we'll also be discussing goal seeking in the next few slides. And formula functions which define the rules of the model are being used. So these are just some benefits. So you probably don't have to memorize all of them, but just probably keep in mind 3 or so, just in case. Some examples of what-if questions in a financial spreadsheet. So if you work with Excel, so this is kind of like an example of what you could be. This might be an extreme form where they're actually showing lots of graphs, pie charts, and the spreadsheet information. It might not be that busy. But some examples of what-if questions in a financial spreadsheet. So in a business, you could ask yourself, what happens to the total income for the month if we increase the selling price by 20%? So you can actually go and do that input values where you increase the selling price by 20%, and then you can see the information outputted in terms of graphs, charts, or just in values. You can see what could happen. What happens to our cost if we use a different supplier for one of our parts? Can also test this out. And what happens to our total expenditure for the next 5 years if we need to move to a new premises? So maybe the new premises has different rents, etc. So you can change the rental value and see what your expenditure will be for the next 5 years. So these are examples of what-if questions in a financial spreadsheet. So examples of goal-seek questions. So if you are working in a financial model, in a spreadsheet still, and the spreadsheet is a financial model of a business or a company, what questions could we ask that would be considered goal-seeking questions? So let's have a look at 2 examples. So one could be, what price do we need to sell a specific item at in order to sell 5,000 items or 5,000 of those specific items per month? So you would have an output cell maybe in your Excel spreadsheet where it's telling you how many items are predicted to be sold in that month. And what you can do is where the selling price of that item is in that spreadsheet, you can just change that value, and then you can just watch the outputted cell value to see at what selling price you could kind of predict you would be able to then sell 5,000 items of that specific item in that month. So that's an example of one goal-seeking question. Another could be, how many items do we have to sell in order to break even? So you would have another section in your Excel sheet, maybe one specific cell, telling you what your profit or loss is going to be of that specific month. And then you can just change the number of items that you predict to sell in that time period. And you just watch the output cell to see at what point or at what value or how many items you would have to sell that would make you have or allow you to break even. So these are just 2 examples of goal-seeking questions in our financial model. What are the limitations of computer models? Okay, so a model is only as good as the rules used to create it. A mistake could have been made by whoever wrote the model. Unless complex rules are used, then the spreadsheet model will never be an accurate representation. Complex rules need mathematical and computer expertise in order to set up, and it can therefore take a long time to create models. And spreadsheets can only be used to simulate numbers, but cannot simulate the effect on the objects. Okay, I hope that was alright. If you have any questions, please let me know.